We already saw what will be the electric field due to a plane sheet. So plane infinitely long sheet, we saw that the electric field, if it is thin, it is sigma divided by 2 epsilon naught, and if it is thick, then both the surfaces will contribute in electric field, and the electric field will be equals to sigma divided by epsilon. So that was due to a single plate. Now what if you have two such plates? Let's say a plate here and another plate here, and they are kept parallel to each other. So if that is the situation, you know that you are going to have, now you can, as you can see here, now if you have two charged plates, let's say both of them are, let me copy this first because we need it in different scenarios. Okay, so let's say these are the two plates. Let's say this one is charged positive and the second one is also charged positive. But let's say this is more densely charged, or the charge density here is more, right? Let's say the charge density here is sigma 1, charge density here is sigma 2, and it is clearly visible that sigma 1 is greater than sigma 2, and both are positively charged. Okay, now whatever be the sigma and all, if two plates are parallel to each other, you will have two different regions. Let's say, sorry, three different regions. Region 1, region 2, which is between those two plates, and region 3. So region 1 and region 3 are outside, and region 2 is in between the two planes. Done. Now here, if we have to find electric field, how are we going to find? So at any point on the left, that is in region 1, there will be electric field due to the first plate, let's say E1, and there will be an electric field due to the second plate, and both of them will be in the same direction. I hope you agree. The electric field due to the first uh, plane will be sigma divided by 2 epsilon naught. So it will be sigma 1 divided by 2 epsilon naught 1. While electric field due to second plate will be sigma divided by, sorry, sigma 2 divided by 2 epsilon naught. So he, and you can see both are in the same direction. Similarly, on the in R3 also, they will be in the same direction. The electric field 1 and electric field 2, they both will be in the same direction, and their magnitude will also be same. So if you finding the total electric field in this region, in this case, when both of them have same nature of charge, positive or negative, both positive or both negative, and sigma 1, on this side the electric field is more, on the second side, the second plane, the the charge density is less. Anyways, so electric field will be what? It will be equal to the sum of these two electric fields. So this will be nothing but sigma 1 plus sigma 2 divided by 2 epsilon naught. And similarly here also you will get the same thing, E1 plus E2, and that's why it will be equal to sigma 1 plus sigma 2 divided by 2 epsilon naught. But what will happen when you are in between the two plates? At any point in between the two plates, the electric field due to E1 will be in this direction, and electric field due to E2 will be in this direction, and the field corresponding to the plate which has higher surface charge density will be more in magnitude. So that means what? E1 is more than E2, and you can see they are in opposite direction. So what will be the electric field here? It will be E1 minus E2. You have to make this, see, this is only an example. So when you are solving this in your exam, you'll have to check which electric field is more. So here, obviously the electric field due to the surface which has higher charge density, that will be more, and that's why this will be equals to sigma 1 minus sigma 2 divided by 2 epsilon naught. It can be even sigma 2 minus sigma 1. That is if sigma 2 is more. So whatever is more minus the second one, charge density divided by 2 epsilon naught. So these are the electric fields. Now, similarly, what if the plates, so this is the case when plates are uh, differently charged. One is positive, another is, when they have the similar charge. What if the plates are oppositely charged? So when the plates are oppositely charged, so I'll draw just one. Let's say this one is positive, and let's say the second one is negative. If this is the case, then what will happen to electric field? Again, there is sigma 1 here, sigma 2 here, and suppose sigma 1 is greater than sigma 2 initially. Okay, so electric field due to 1 will be this, but what will be electric field due to the second field, or due to the second plate? Due to the second plate, the electric field will be in the opposite direction towards the negative charge. So this is E2. And obviously E1 will be greater than E2 if E1 is more. And because they are opposite, right? Because they are in opposite directions. So what is the total electric field here in this case? Total electric field here in this case will be E1 minus E2. That is in region 1. So this will be equals to sigma 1 minus sigma 2 divided by 2 epsilon naught. And similarly here, it will be uh, also E1 minus E2, that is sigma 1 minus sigma 2 divided by 2 epsilon naught. So that is the region 1 and region 3. What about the region in between? So if you see here, due to positive charge, electric field will be in this direction, that is E1. And due to negative charge, electric field will be also in the same direction, that is towards the negative plate. And that's why if you are finding the total electric field in between, that is in region 2, it is going to be E1 plus E2, that is sigma 1 plus sigma 2 divided by 2 epsilon naught, right? And that's why what if sigma 1 is equals to sigma 2? What if this is the situation? If that is the situation, you know that E in the first case will become what? 0. Third region, 0, right? Sigma 1 minus sigma 2, and sigma 1 and sigma 2 are same. So that's why it will be 0. But in the region in between, E will be equals to sigma divided by 2 epsilon naught, or sigma plus sigma divided by 2 epsilon naught. That means electric field will be equals to sigma divided by epsilon naught, right? So when the two plates have same charge density, the electric field between the plates is sigma divided by epsilon naught. This is something which we will be using later when we will study capacitors, the parallel plate capacitors. So remember this: the field between the two plates, the field at a point which is between the two plates, two parallel plates having same charge density, is sigma divided by epsilon naught. If the charge densities are different, then it is sigma 1 plus sigma 2 by 2 epsilon naught, or sigma 1 minus sigma 2 divided by 2 epsilon naught, depending on whether the charges are like or opposite or dislike, unlike charge. Okay, so that is about the parallel plane sheets of charges.